Hello students, welcome to the first video, part 1 of our next chapter, alternating current. In this chapter, we will be discussing about the alternating current and its effect when it will be passing through different components like resistor, capacitor and inductor. So what is an alternating current? A current whose magnitude varies with time and direction reverses periodically is known as the alternating current. So here in the figure you can see the graphical representation of an alternating current, which is a graph between the current taken on the x-axis and time taken on the y-axis and time on the x-axis. Mathematically, we can represent an alternating current with I is equal to I naught sine omega t, where I is the instantaneous value of the current at any time t and I naught is known as the peak value of the current or the maximum value of the current, or we also call it as the current amplitude. We can show it on the graph with this arrow. This is the current amplitude. The current which is having value 0 to its maximum amplitude in any direction, positive or negative, we call it as the current amplitude. So this is I naught. So 0 to in the positive direction it will be plus I naught. From 0 to in the negative direction it will be minus I naught. So if we measure the total current from one peak to the another peak, that is from negative direction to the positive direction, it will be double the peak value, that is 2 I naught. We call it as the peak to peak value. This type of current is known as the peak to peak value. The time taken to complete one AC cycle, we call it as the time period. So AC cycle starts from over here and complete itself over here. So from point O to the point A, we have one AC cycle. From A to B, we have the new alternating cycle. One alternating cycle, it can be divided into two equal halves. One half is known as positive half cycle, which lies in the positive region. So this particular portion, we call it as the positive half cycle. This is the positive half cycle, and this particular region we call it as the negative half cycle. So time taken to complete one complete cycle of AC, we call it as a time period, and time period T is given as T is equal to 2 pi over omega, where omega is the angular velocity of a coil rotating inside a uniform magnetic field, which is going to induce an alternating current mathematically, which is given as I equal to I naught sine omega t. We will study in AC generator. Frequency is the number of the cycles of the AC completed in 1 second. Because frequency is reciprocal of time, so it will be 1 over t, it will be omega over 2 pi. When we are trying to measure an alternating current, DC voltmeter, ammeter or moving coil galvanometers are not useful for us. Reason? Because all these devices, they are based upon the magnetic effects of the current. We know that direct current doesn't change its value and direction also. So they are based upon their measurement is based upon their magnetic effects which they produce. But they are not suitable for the alternating current. Reason? Because we have seen that alternating current periodically reverses its direction. So if this type of current is passed through, say, an DC ammeter, it is going to move the pointer in one direction, but when the other half cycle, the opposite half cycle will appear. It is going to move the pointer in the opposite direction. And if we are trying to measure the common household AC, which is having a frequency of 50 hertz, then this type of AC pass through the DC emitter is not going to make any movement in the pointer. Reason being, if the AC frequency is 50 hertz, then the time period of one AC cycle, it is 0.02 second. This means that one half cycle of the AC is existing only for a time of 0.01 second. So for such a short interval, the AC cycle half cycles are reversing their directions, because of which the pointer cannot change its position rapidly. So it will stand still. So it is not going to move at all in any direction. So AC is not measurable with the DC voltmeter, ammeter or the galvanometers. From here we can conclude an important point, that average value of AC over one complete cycle is 0. So you can see that in the positive half cycle the current is plus I naught, but in the negative half cycle the current is minus I naught. So if we measure the average value or the mean value, it will be equal to plus I naught plus minus I naught divided by 2, which will be equal to 0. So instead of measuring AC on the magnetic effects of the current, we measure AC using the hot wire instruments. AC is measured using the hot wire instruments, which are based upon the heating effects of the current. If you remember, Joule's law of heating effect says that H is equal to I square R into T. So heat produced is directly proportional to the square of the current. So when squaring of the current takes place, even the negative half cycles are also squared. So the squared current does not contain any negative half cycle, all cycles are positive. So in this case, the amount of heat produced is no more dependent upon the direction of the flow of the current. So all AC measurements are based upon the heating effects of the current. So all AC ammeters, voltmeter, they employ this technique to measure the alternating current cycle. Thank you.